Stats performance test. So in this video, I'm going to be explaining the answers for 1 and 4. Number 1, 31% of workers in the US are college graduates. You randomly select 50 workers and ask each if he or she is college graduate. So in this question, this is a normal approximation to binomial distribution question. So first, you have to find the P, Q, and N. So our P is 31%, which is 0.31. U will always be the complement of P, so we subtract 1 by 0.31, which is 0.69. And our N is 50, since we randomly select 50 workers. Now, you have to get the mean and standard dev. Formula for mu or mean is NP, which is 5 times 0.31, which is 15.5. And then the formula for standard dev is square root of NPQ, which is square root of 5 times 0.69 times 0.31, which is approximately equal to 3.27. Now we have these values. We can now get the z's. So first you have to find the formula. So since it says exactly 14 workers, our formula is P of x equals A. So the formula for that is P times A minus 0.5, or x in between A minus 0.5 and A plus 0.5. And our A is 14, that says in the question. So we substitute, this will become 14. So 14 minus 0.5 is 13.5 in between, and 14 plus 0.5 is 14.5. Now you have this. Now you can find the z. So the formula for z is value minus mean over standard dev. So we have two z's here. So first, z1, value minus mean, 13.5 minus mean, which our mean is 15.5, we got earlier. And our standard dev is 3.87, which is equal to negative 0.61. And our z2 is value minus mean, 14.5 minus 15.5 over 3.27, which is equal to negative 0.31. So in the normal approximation table, negative 0.61 is 0.2709. And for negative 0.31, it is 0.3783. And since it's between, you have to subtract these two z values together. So the area between the two z values is 0.3783 minus 0.2709, which is equal to 0.1074, or 10.74%. Now that's the answer for A. Next, letter B. So find the probability that at least 14 workers are college graduates. So at least, it says at least 14 workers. So it is greater than or equal to our sign. So x greater than or equal to A. So the formula here is x greater than A minus 0.5. So our A is still 14. So this is x greater than 14 minus 0.5 is 13.5. So next we find the z values, value minus mean over standard dev, which is, we only have one z value this time. So 13.5 minus 15.5 over standard dev, 3.27, which is still equal to negative 0.61. We got this earlier in letter A. Next, since it's to the right or greater than, we're finding the area to the right of z. So if it's always to the right, we subtract it by 1. So negative 0.61 is, in the table, it's 0.2709. And since it's to the right, you subtract it by 1. So 1 minus 0.2709 is equal to 0.7291 or 72.91%, and that is our answer. For letter C, says find the probability that fewer than 14 workers are college graduates. So since it's fewer, our sign will be less than this time. So our formula here is P of X less than A minus 0.5. So it's still the same. Our A is 14. And if you subtract by 0.5, it's 13.5. And then value minus mean over standard dev to get the Z. 13.5 minus 15.5 over 3.27. It's still negative 0.61. And negative 0.61 is 0.2709. So that is our answer. If it's to the left, you don't have to subtract anything else. So our answer is 2709.2709 or 27.09%. That's our answer for letter C. And for number 1 also. Next, number 4. A sociologist found that in a sample 50 retired men, the average number of jobs they had during their lifetime was 7.2. The population standard dev is 2.1. So for number 4, this is central limit theorem. So first, here you have to find the mean and the population standard dev. So our mean is 7.2. It's in the question, and our standard dev is 2.1. Next, letter A. Find the best point estimate of the mean. So the best point estimate is the x bar, and the x bar is equal to mean. So our point estimate is equal to the mean, which is 7.2. For letter D, find the 95% confidence interval of the mean number of jobs. So 95% is always 1.96. So that's our ZC. ZC is 1.96. So we need to get the ZC and the sample standard dev or standard x bar. So our formula for standard x bar is 2.1 over square root of 50. Or this is standard dev over square root of n. So this is approximately equal to 0.30. Next, we find the margin error or E. So to get the margin error, you need to times the ZC to the standard x bar. So 1.96 times 0.30. This is equal to 0.588. And next, the next thing you do, so this is the formula. So mu in between x bar minus E for margin error and x bar plus E. So you substitute, you have all these values discovered already. So our x bar is 7.2 minus our margin error, which is 0.588. Then in between mu, 7.2 plus 0.588. So the minus will be 6.612 in between mu, and for the plus 7.788. And that is our answer for letter A. So to interpret this, we are 98% confident that the mean in this interval is in between 6.612 and 7.788. Next, letter C. So for letter C, it says find the 99% confidence interval of the mean number of jobs. So 99% will always be equal to 2.575. So that's our ZC. And we need the standard x bar, it's still the same. And next, get the margin of error, which is 2.575 times 0.30. This is the ZC and the standard X bar, which approximately equals to 0.7725. That's our margin of error. Next, use the same formula, mu in between X bar minus E and X bar plus E. So substitute 7.2 minus RE, 0.7725 mu in between 7.2 plus 0.7725. And to simplify, this is 6.4275 mu in between. This is 7.9225. 7.7925. Sorry, 7.7925. So that is our answer for letter C. Now, lastly, letter D, which is smaller. Explain why. The smaller one is part A. This is because the margin error for part A is much smaller than the margin of error in part B. So the smaller one is part A because basically the margin of error in part A is smaller and the margin of error in part B is larger. And that is it. Thank you.